Hi everyone and welcome to my little workshop. In this project video I'm going to do something a little bit different. I'm going to build a jig, this jig in fact, which is essentially an angled shooting board which I can use for cutting a 45-degree mitre along the edge of a board. Why do this, you may ask? Well, one of the frustrations of an enthusiastic new woodworker is that there are a lot of interesting and inspiring projects out there, but many require either specialist tools or an investment in expensive machine tools like a table saw or bandsaw. A classic example are boxes with mitre corner joints and splines, like these ones I've made over the years. It's tough to find a method for making these which doesn't rely on access to a table saw or bandsaw at some point in the construction process. Now, as all woodworkers know, the only way to improve is by doing. So, finding a project and getting on with it is of paramount importance. And if you keep putting off a project until you kitted out that perfect workshop, you're never going to get started. I acquired all my tools over many years, starting out with just the most basic. So I decided to challenge myself and find a method for building a nice mitre-cornered box using only the most basic hand tools which a beginner might have or could reasonably be expected to acquire. Also, a mitre-joined box relies on the accuracy of the mitre cut itself, so whatever method I came up with needed to include a way of ensuring that accuracy, even for a novice woodworker. Which brings us to this jig. I found a few examples online of shooting board jigs that could do the job, but without exception these all relied on access to some kind of machine saw at some point in the construction process, either that or some kind of specialist hand tool that was capable of cutting a very accurate 45-degree angle over a length of board. I thought it would only be useful to build a box using the basic hand tools if the jig that I relied on could also be constructed using those self-same basic hand tools and novice skills. So this is what I came up with.
The materials I'm using are all things that I had lurking around the workshop. For the base I'm going to use this bit of old furniture board. This construction timber will be used for the frame. And I have this bit of wood that originally came off an old bed frame. The final thing I use are some lollipop or popsicle sticks. The exact materials don't really matter, but I've chosen these because they've all been engineered in a factory and therefore I can trust the squareness and the regularity of the dimensions. As I said in the introduction, the ultimate aim of this project is to be able to build a mitre-cornered box using a minimum of hand tools. And these are the tools I'm going to use. For markout I have a combination square which allows me to do 90 and 45-degree angles, and I use a sharp knife for making all the marks. I'm assuming a novice won't have a large range of saws and planes, so I'm going to use a single tenon saw and the most common hand plane, the number 4. First of all I'm going to use the piece from the old bed frame to make the rails. And I need two pieces of equal length, so I'm just going to cut this in half. I mark the halfway point and then using a square and knife I trace the mark onto all sides of the wood. Next, I use a chisel to cut up to the knife mark. This provides a good guide for sawing and helps to make a clean cut. Next, I use a tenon saw to cut through the piece of wood, using the knife marks as a visual guide. And I have two pieces the same length. These pieces are going to act as the guides for the plane to run against. Something like this. If we turn the plane over and look at the sole, we can see that there is a gap between the edge of the cutting iron and the edge of the plane. This gap is where the plane will run on the rails to help it in the guide in the jig, and I'm going to use these popsicle sticks as a way of making those rails. A 2-layer thickness of popsicle sticks will make the rails. First of all, I'm going to cut the rounded ends off of the popsicle sticks so that they can butt up against each other nicely. I set my marking gauge to the same width as the popsicle stick and score down the inside of each of the guides. One of the 3 parts of this jig which require absolute precision are the height of the rails which the plane will travel along. These need to be identical on both guides. These gauge marks and the use of popsicle sticks which have a uniform width allow me to ensure this precision. I line up one of the guide rails with the gauge mark on the other rail and clamp everything in place. This is going to help me when I come to stick the popsicle sticks in place. The exposed surface of this first guide should now be exactly the same width as the popsicle stick along its entire length. I add some wood glue to the surface of the first guide and then put the first row of popsicle sticks in place. I slide them back and forth to make sure there's a good coverage of glue and also to make sure there's glue between the edges of each stick. With this first layer in place, I add some more glue ready for the second layer of popsicle sticks. I make sure I add this second layer of sticks so that they bridge the gaps on the first layer. Popsicle sticks, or lollipop sticks as we call them in the UK, are great for this kind of application, as they are manufactured in a factory and therefore have a uniform thickness, length and width. With the sticks in place, I take some paper tape and put it over the top layer. Then using a piece of scrap wood, I'm going to clamp everything in place. With this piece of scrap wood being clamped across the length of the popsicle sticks and holding them in place, I can remove my first guide piece. I then wipe away any glue squeeze out, and also the glue that's got on the other guide piece. And I'll leave that to dry. After repeating this process on the other guide, I now have 2 guides with rails attached, and the plane sits on the rails like so. Using a tenon saw, I cut off the excess popsicle stick from the end of each guide. Next, let's turn our attention to the frame of the jig. I need to mark an accurate 45-degree angle, which I could do with a speed square, but I'm going to use my combination square. I mark the line in with a knife. I'll add a pencil mark just to make it easier to see on the video. I trace this square mark around the top of the piece. And I can now mark on the corresponding 45-degree angle on the other side. As before, I'm going to use a chisel to help make a guide for the saw. This 45-degree angle needs to be cut very precisely. It's the second of the 3 crucial measurements and angles within the jig. So I'm going to use another piece of scrap wood in order to make a guide. First, I drill a couple of holes in this piece of scrap. This drill cost me about £2 from a flea market, and after spending some time cleaning it up, it works perfectly. I'm going to countersink those holes now. The exact size of this scrap piece of wood is irrelevant, it just needs to have a guaranteed straight edge. Using my combination square to line everything up, I'm going to put this guide on top of my workpiece and then screw it down, lining up the edge of the scrap with the line I want to cut. I can now cut the 45-degree angle on my piece of work using this guide. By ensuring that the saw blade is flat against the guide, I can ensure that the cut is perpendicular all the way across the piece of work. I take my time on this cut because I want to ensure its precision. There's a nice shot of my hat. With the cut made, I'll check for square across the face. And with the guide still in place and my plane set on a very shallow cut, I'll just tidy up the end. I use the guide to reference the sole of the plane to ensure everything stays square. And when that's all finished, I can remove my scrap guide piece. I'm not worried about the holes this will leave in the frame, this is only a jig after all. I'm going to need 2 of these pieces, so I mark this one for length and make the second frame piece from the rest of this length of timber. And there we go. The length of my guide pieces dictates the width of the jig, and so I'm going to use this to mark up the base. Using a square, I mark up the position for the edge of the base. I'll place the frame pieces in position and then mark the other side. I'm going to be screwing these frame pieces to the base, so marking up the width gives me the ability to find where I should place those holes. I'm just checking the board is indeed square, which it is. I mark up where I want to drill the holes and then use a centre punch. This will help guide the drill bit, especially on this slippery piece of wood. I then drill the holes. I then countersink each of these holes. I'm now ready to start constructing the jig. I do so by fixing the first of the frame sides. The glue will only be so effective on a shiny material like this, but I am going to screw these pieces in place. I'm using this material for the base purely because I had it lying around and couldn't think of anything more useful for it. I would probably have been more happy using a good piece of plywood. With the frame side glued and held in place with clamps, I'm going to drill some pilot holes through the holes in the base. I then screw the sides to the base. Next, I'm going to cut the base to length. I'm using a piece of scrap wood to line up with the mark I made for the edge. The third of the three crucial measurements within this jig relate to the position of the side frame pieces. It's imperative that both sides are perfectly parallel and that the 45-degree faces are in perfect alignment. In order to help here, I'm going to make sure that all the cuts to the baseboard are perfect 90-degree angles so that I can reference off the front and side edges. Using the tenon saw, I make a mark ready to cut the full length of the board. With this mark in place, I remove the side piece and use the tenon saw to cut across the board. If you have access to more saws, it would be useful to use a handsaw here to cut the length of the board. But I committed to doing this job with a minimum of tools, and so I'm going to use a tenon saw. I cut this by starting in and cutting from both ends, leaving the middle intact, and then cutting down the middle of the board. I'm using my workbench for this job, but it's just as possible to do it using a table and clamps, or by using something like a Black & Decker workmate. I'm now going to fix the other frame side. Using the square, I line everything up, and then I'm going to clamp it in place. By referencing the front edge of the base for both sides, I can ensure that they are parallel. These one-handed clamps are very useful for this kind of job. It's crucial that the frame sides are perpendicular to the front of the jig, and so I'll spend some time with the square making sure this is lined up properly. Next I flip over and I'm going to attach just one screw. This is on the front of the edge, nearest the 45-degree angle. The reason I didn't fit the rear screw at this point is so that this side piece can swing. It gives me some potential for making small adjustments to the squareness of the jig. I'll add that second screw to lock this frame piece in position once I've done some test cuts and adjusted where necessary. Next I'm going to connect the guides to the front of the jig. So first of all I need to drill some holes. I'm going to drill holes that will allow me to screw the guide pieces into the dead centre of the angled fronts of the frame. As per usual, I'm going to countersink these holes. This is because I don't want any screw heads at all poking out anywhere where my plane iron might travel. I use some paper tape to act as a third hand while I position the guides. I made sure that the side pieces of the frame were set back a little way from the front of the base. This gives me a small amount of room for the guide to rest on. This helps in keeping everything square. But only, of course, if that distance is the same on both sides of the frame. With the guide in position, I drill the first pilot hole. I want to get this as square as possible, but actually it's not as important, because if the plane skews across the front of the face, it will still cut at a 45-degree angle. What's most important is that the rails on the inner of the guide are identical top and bottom. I use my combination square again to make sure everything is lined up nicely. And the great thing about combination square is I can take reference of both sides of the frame. After drilling the pilot hole, I can finally screw this guide in position. Next for the top guide. I'm going to position this top guide so that the jig is ready to accept my number 4 plane. The two guides need to be close enough that the plane doesn't wobble from side to side too much. Also, it's important that the guides aren't positioned so tightly that the plane is nipped and has trouble moving. Therefore, I'm just going to make a little spacer by folding a piece of paper tape that I can insert between the plane and the guide while I fit it. Once more I drill a pilot hole, and then I can screw the guide in place. I position the plane and the spacer and attach the other side of the guide. And this is the construction more or less completed. As I said, it's not crucial that these two guides are parallel. What is crucial is that the depth of the rails are identical top and bottom. Otherwise this will compromise the 45-degree angle. This is the waste material from my initial 45-degree cut, and I can use it just to check the angle across the length of the guides. Now to check the jig. I'm ensuring that my test piece is perfectly square because I'm going to line it up against the edge of the frame. Then placing my plane on the rails, I'll move it backwards and forwards and slowly feed the workpiece in using my fingers. By lining the end of the workpiece against the frame, I should get a perfect 90 degrees. Therefore the plane should be running perfectly perpendicular and the angle should be spot on. That looks pretty good. I can check this angle by measuring its width. Top and bottom should be exactly the same, which it is. Now I'm happy with the setup, I can permanently fix the last side. In this setup of the jig, I have made sure that my plane is correctly set and that my cutting iron is completely square to the sole of the plane. In order to cut a mitre across the entire width of a piece of material, I use that test piece as a stage to move my workpiece up into the path of the plane. I'll do a final check with the square to ensure that the surface of the mitre is perfectly perpendicular with the edge. And that's it. I can use this jig with a range of planes simply by unscrewing the top guide and adjusting its position. In my next video, I'll show you how I made this mitre-edged box using simple hand tools and the jig we've just constructed. I hope you found this video useful, and if you did, please consider subscribing for more projects.